All right, so section 8.7, dilations. Okay. And a dilation with center C and scale factor K is a transformation that maps every point P in the plane to a point P prime. That's what that little mark right there would be read as prime. So the following properties are true. If P is not the center point C, then the image point P prime lies on ray CP. Scale factor K is a positive number such that K is equal to the length or the distance from C to P prime over the distance from C to P. Or in other words, the distance from the center point to the new point over the distance from the center point to the original point. And if P happens to be the center point C, so if the center point and point P happen to be the same point, then P and P prime will be the same value. And we mapped it in the same spot. We've got two types of dilations. One is a reduction, which is going to have a scale factor or K value between 0 and 1. So it's going to be a fraction, just a regular fraction, 1/2, 1/3, 2/3, 2/4, something like that. And enlargement is going to have a K value or scale factor that is greater than 1. So could be a improper fraction or a whole number that's greater than 1. One thing we can't have is a K value that's equal to 1, because that would mean that there was really no change. If the scale factor is 1, then all the original points are going to be the same as all of the prime points. So here's an example of a reduction, starting with our original points P, Q, and R. P, Q, R. And our dilated points P prime, Q prime, R prime. So this is the original triangle. This is the dilation of that triangle, which should be kind of clear to see that you're starting with a big triangle. The new triangle is a smaller triangle, so that's a reduction. And our K value, our scale factor, takes the distance from the C, the center point of where these rays originate from, to the prime point. So that's a distance of 3, and then that's over the distance from the C point or center point to the original P value, which is 6. So 3 over 6. Alright, so then this next one, example of an enlargement, which you can see your original PQR is a small triangle, and the P prime, Q prime, R prime is a larger triangle. The distance from the C point to the prime point P is a distance of 5, and that would go over the distance from C to the original P, which is 2. So 5 over 2, which is greater than 1. That also tells us it's an enlargement. Alright, so then next one's we want to identify the dilation and find the scale factor. So dilation should be easy to tell when you got a picture. Maybe a little bit more difficult if they just give you the points. So from the picture, what kind of dilation does that first one look like? These are our prime points, A prime, B prime, D prime, and then we got A, B, and D here. So the original points make a little triangle. Prime points make a big triangle, so that would be an example of what? Reduction or enlargement? It's an enlargement. And then that scale factor for the enlargement. It's going to be the distance from C to the prime over C to the original. So what's the distance from C to the prime value? C to the prime is 7, and that's over C to the original, which is, distance from C to the original is 3. So it's an enlargement with a scale factor of 7 over 3. And the next one, we look at our K value. C to the prime value is 3. And how far is it from C to the original Q? So looking for the whole distance here. So 3 and 1 add up to 4. So our K value is 3/4, which is less than 1. So that makes that what? Reduction or enlargement? So reduction. So reduction, K values less than 1, 3/4. Enlargement, K values bigger than 1, 7/3, which is actually what, 2 1/3. All right, so then in a coordinate plane, so instead of just having a random picture, if we put these in a coordinate plane where we have coordinates plugged in, and with the dilation whose center is at the origin, which that's all we're going to deal with here, is dilations where the center is at the origin, because it gets a little more difficult if we do it otherwise. But with the center at the origin, the image of P, which would be the point xy, is going to be P prime, which will be K times x, K times y. So basically what that's saying is we start with the original point, which is our xy, and to get the points after the dilation occurs, we take the scale factor K, multiply it times the x and the y value, and that'll give us the new coordinates for the prime values. So here we want to draw a dilation of triangle ABC with A equals -2, 1. Alright, so the dilation of triangle ABC with A is -2, 1, B is -6, 0, C -1, -1. Our origin is going to be the center, and we're using a scale factor of 3/2. So the original triangle has an A value of -2, 1. Gotta put our A right there. B is -6, 0, so right on the line here. And C is -1, -1. And then from there we want to create the dilation. Right, so this is our original triangle. And now, starting off, point A is -2, 1. Our K value is 3/2. So to get A prime, we're going to take our scale factor, 3/2, and multiply it times the original coordinates. So 3/2 times -2, and 3/2 times 1. So A prime, once we multiply that through, 3/2 times -2 would be -6/2, or it would be -3. 3/2 times 1 would just be 3/2, or 1 1/2. So our new A point, or our A prime, so we at -3, 3/2, so up 1 and 1/2. There's A prime. And then our B value was -6, 0. So for B prime, I'm going to take our scale factor 3/2 times those coordinates. So 3/2 times -6 will be -18/2 or -9. 3/2 times 0 is 0. So B prime is at -9, 0, so right on the x-axis at -9. And then our C coordinate, -1, -1. And for C prime, 3/2 times -1, 3/2 times -1. So that'll be -3/2, -3/2. So, or -1.5, -1.5. So right there in the center of that square right there will be our C prime. Connect the dots to make our triangle. And try that again. It's not very straight. So there's our dilation, which if we draw in the rays from our center point, which our center point was the origin, right? So we draw in a ray from each one of those. From the center point, draw that ray from the center point, it should go through both of our points, the original point and the prime point. So this ray goes from the center, hits A and A prime, goes from the center, hits C and C prime, and there could be one more that goes straight down the x-axis. Right? It's going to hit B and B prime. So when you put that dilation into the graph with the original image, or the pre-image, I should say, because the prime version is the image. So when you see dilations and we talk about the image, that's what happens after the dilation occurs. So that's the prime stuff. The pre-image is before we draw the dilation or the original points. Questions on any of that?